Hello and welcome. In the matching tutorial for beginners, we created a simple matching program similar to this one. In this tutorial, we examine options for processing the results of the matching function. First, you might want to count how many matches you found. One way to do this is to determine the length of one of the result tuples. For example, score. You can do this quickly by enclosing score in vertical bars. Then we use dispMessage to display a message containing the string matches, followed by the number of matches that we just calculated. Additionally, you might want to display the score next to each match. Since score has a lot of decimal places, we might want to round it before visualizing it. In the HDevelop User's Guide, Chapter 8.5.8 String Operations, you can find some examples on string conversion. To round score to 2 decimal places, we type this line. Note that score rounded is no longer a number, but a string. Then we display the message next to every match. We have to set the chord system to image, since the content of the message is related directly to the image. Now, when stepping through the program, the number of matches is displayed, and the visualization of the score gives you a good impression of how well the objects match the shape model used for searching. Next, I will show you how to realign the region of interest used to create the shape model with the matching result. To do this, we need to tell the original region how to move from where it was created to where it should be according to the matching. In HDevelop, we can do this with a transformation matrix. Double-click on Find Shape Model, and then Help. Here you can find an example showing how to create a similar matrix. We need the operator vector angle to rigid. The operator needs 2 sets of coordinates, the original coordinates and the destination coordinates. First, we need the coordinates of the original region of interest. We insert the operator area center to get them. Then we adjust the respective parameters of vector angle to rigid. The destination coordinates of vector angle to rigid are the coordinates found by the matching. When executing the operator, we get a transformation matrix. Next, we need to actually move the region. The movement is an affine transformation. We need the operator affine trans region. The input parameters are already set correctly. We transform the region ROI0 according to HomeMate2D. The resulting region, region affine trans, is our desired result. Lastly, we insert the devDisplay operator to visualize the region. When running the program, we can see that the region is transformed correctly. But there is a problem. When multiple models are found, we run into an exception. Vector angle to rigid can't compute a transformation matrix when multiple coordinates are passed, like they are here. Instead, we have to use a for loop to loop through all the matches separately. Control tuples begin with the index 0, so we loop from 0 to numMatches minus 1. Then we cut and paste the operators vector angle to rigid, affine trans region, and devDisplay inside this loop, and correct the formatting. Lastly, we adjust row, column, and angle to access the appropriate values. Now the region is transformed for every match separately. Alternatively, in some applications, you might instead want to rotate the image such that the object is always oriented the same. To do this, we again use Vector Angle to Rigid. We want to move the image from where it was found to the reference position, defined by ROI 0. In this case, the coordinates found by the matching are the origin, and the coordinates of ROI 0 are the destination. Next, we use the operator affine trans image to transform the image accordingly. For better visualization, we clear the window first and then display the result. Lastly, we cut and paste the stop into the loop so the program stops after every transformation of every match in each image. When running the program, we can see that all matches appear in the same orientation. This concludes our video. You should now be able to realign your regions of interest or images after matching and do some basic things with the results. In the next video, we will take a closer look at some advanced parameters of the matching operators. Thank you for watching.